Module 4, Lesson 9, Writing Addition and Subtraction Expressions. Learning target: I can write expressions that record addition and subtraction operations with numbers. We're going to start by using 3 plus 5, and we're going to first create a bar diagram that is going to show 3 plus 5. So in blue, I have drawn 3 boxes to represent the 3. And in yellow, I have attached 5 boxes to show 5. So altogether, this shows 3 plus 5. But what if we reversed it and we had 5 plus 3? What would a bar diagram look like then? So now we have first 5 boxes in yellow, and then attached to that we have 3 boxes in blue, and this shows 5 plus 3. So looking at both of these expressions, are they equivalent? Yes, they are both equivalent because 3 plus 5 and 5 plus 3 equal 8. So how could we show in an expression that a number is increased by 2? So we're going to have to use a variable here. And I'm going to choose A as our variable. And then increased means that we are adding 2. So this expression shows that a number is increasing by 2. Or you could say 2 plus A. They are exactly the same. Can we prove this using a model? We sure can. Both of the bar diagrams that I have drawn show A plus 2 or 2 plus A. Both show that a number is increasing by 2. So now how can we show in an expression the sum of M and K? So a key word here is sum. So this tells us that we are going to be adding. So we're going to be adding M and K together, or you could do K plus M. So which property can be used in the last 3 examples that we have done together that show both expressions are equivalent? So these last 3 examples show the commutative property of addition. And remember that the commutative property of addition just simply tells us that when we are adding numbers together, order does not matter. So how can we show 10 minus 6 using a bar diagram? So I have drawn a bar diagram with 6 boxes, and now we have to show the minus 6. So we're going to shade in 6 boxes. So I have shaded in 6 boxes, and now this diagram shows 10 minus 6. So what expression would represent this model? The expression that represents this model is 10 minus 6. Could we also do 6 minus 10? No, we cannot do 6 minus 10 because if we started with 6, then took away 10, the models wouldn't match. And remember, if you are subtracting a smaller number from a bigger number, you're going to get a negative number. And the answers to this expressions are 4 and negative 4, and these are not the same thing. They are 2 different numbers. So no, we cannot also do 6 minus 10. So how can we show, using a model, 3 less than a number? And our key here is less than. So this tells us that we are going to be subtracting 3 from a number. So let's draw our model. So I have drawn one big rectangle, and that one big rectangle is going to represent n, which is a number. And within that rectangle, I have drawn one smaller box and written 3 in it. And that is showing that 3 is being subtracted from the number. So 3 less than a number. So what expression would represent this model? The expression that represents this model is n minus 3. So we're taking that number, whatever the number is, and we're subtracting 3 from it. So now how would we show, using an expression, that number c is being subtracted from the sum a and b? Let's start by writing an expression for the sum of a and b. So sum tells us that we are adding. So we can either have a plus b or b plus a. Remember, when we are adding, order does not matter. Now, how can we show c being subtracted from the sum? So the minus c is going to come at the end of our expression because we want to do that part last, because we're subtracting it from the sum of a and b. So a plus b or b plus a needs to come first in our expression. So we, using order of operations, do the adding first and then the subtraction. So we can have a plus b minus c or b plus a minus c. So now, how would we write an expression that represents number c minus the sum of a and b? So we're no longer subtracting c from a and b. So c is going to come first. So c minus the sum of a and b. So it's going to be c minus the sum of a and b. And we want a and b in parentheses because we're subtracting c from the sum of a and b. So in order to do that, we have to add a and b together. And if you don't put it in parentheses, then you wouldn't be adding together first, because order of operations says for addition and subtraction, you go from left to right. So you would actually be doing c minus a plus b. And that's going to give you something totally different. And let's try it out so you can see what I'm talking about. So I have assigned numbers to all of our letters. So a is going to equal 1, b is going to equal 2, and c is going to equal 3. So let's solve the expression that we just came up with using our numbers. So we're going to have 3 minus the sum of a plus b. So this becomes 3. So this becomes 3 minus 3. And I've done the addition first because it's in parentheses. So I've done 1 plus 2, which gives me 3. So now we have 3 minus 3, which gives us an answer of 0. But what's going to happen if we don't have the parentheses? Our equation would read c minus a plus b. Now let's plug in our number. So now we can plug in our numbers. So we're going to have 3 minus 1 plus 2. In order of operations for addition and subtraction, say that we just solved the equation or the expression going from left to right. So we're going to do the 3 minus 1 first, which gives us 2. And now we have 2 plus 2, which gives us 4. And these two answers, 0 and 4, are not the same thing. They do not equal each other. And that is why you need the parentheses in this expression, so that we know that we have to do the addition problem first. Otherwise, we are not going to be getting the correct answer. So now let's just do some practice problems writing expressions. So the first expression we're going to write is the sum of 7 and 1.5. What expression is going to show the sum of 7 and 1.5? So sum tells us that we are adding, so we can have 7 plus 1.5 or 1.5 plus 7 because according to the commutative property of addition, order does not matter. So now what expression is going to show W increased by 4? So increased by tells us that we are going to be adding. So we can have W plus 4 or 4 plus W. So now what expression can represent the sum of A, B, C? So sum tells us we are adding, and I have just given 3 examples, but there are several more because order does not matter when you are adding. So my examples are A plus B plus C, B plus C plus A, and C plus A plus B. So now let's come up with an expression that's going to represent 3 less than P. So less than is telling us that we're subtracting, and it's telling us that we're going to be subtracting 3 from P. So our expression is going to be P minus 3. Now let's write an expression that's going to show the difference of 3 and P. So difference tells us that we are subtracting of 3 and P. So we know that 3 is going to come first and P is going to come second. So our expression is going to be 3 minus P. And now let's come up with an expression that is going to show 4 less than the sum of G and 5. So we know that less than means we're going to be subtracting 4 from the sum of G and 5. And sum tells us that we're going to be adding G and 5 together. And we want to do the sum first. So G plus 5 is going to come first in our expression, and then the minus 4. So your expression can either read G plus 5 minus 4 or 5 plus G minus 4. But either way, you want the addition part first and then the subtraction part. And our last example, we're going to write an expression that shows 4 decreased by the sum of G and 5. So decrease tells us we're subtracting, so we're going to be subtracting 4 from the sum of G and 5. Sum adding, so we're going to need to add G and 5 together. So 4 in this case is going to come first because 4 is decreased by the sum. So it's going to be 4 minus G plus 5, but you want the G plus 5 in parentheses because we have to make sure that we're doing the sum first. We're doing the adding part first. So that has to be in parentheses. So your expression can be 4 minus G plus 5 in parentheses, or 4 minus 5 plus G in parentheses. And that's it. Now go complete the problem set.